Okay. Hey, real quick, before I clear this, what's going on here is we're using the limit process, and I'm trying to graphically explain to you what the limit process is doing. Just take any point x. If I put in x, I would normally call it y, but we're going to call it f of x here. So that stands for any point. Now, add something tiny to the x. Okay? And then the output of that is going to be represented by that notation. So far, so good? So if we did f of x plus delta x minus f of x over x plus delta x minus x, okay, that is just the slope formula. And keep in mind that x minus x is gone. That's 0. So you might recognize this as it's part of the process of finding the derivative. Well, if we take the limit as delta x approaches 0, then this line will turn into a tangent. Does that make sense? And that's going to be the derivative equation. So that's what we're doing. Okay, so now let's do that process for this equation. We're looking for f of x plus delta x minus f of x over delta x. And we're taking the limit as delta x approaches 0. We can't just plug 0 in because it's going to give us divided by 0 error, so we have to mess with this. So here we go. How do we find f of 3? Put 3 in for x. So how do you find f of x plus delta x? That's right. That's right. So it's going to be x plus delta x squared plus x plus delta x plus 2. Okay? That is this. And then minus, and you want to use a parentheses for this minus.
Plus 2 or minus 2?
It should be a minus 2. Thank you. Okay? All right. Minus, and then f of x is just x squared plus x minus 2. Very common mistake. People forget the parentheses there, and they only subtract the x squared. All over delta x. I know we're taking the limit as delta x approaches 0. I'll put that limit in once we get rid of the delta x from the bottom. So now I got a FOIL. So I don't know. I'd like to grow out of having to write down the FOIL. Do you think you can FOIL that?
Yes.
Without writing it out? So go give it a shot. Let's see what we get.
X squared.
X squared.
Plus 2x delta x.
Plus 2x delta x.
Plus delta x squared.
Thank you. Very good. Plus delta x squared. And then plus x plus delta x minus 2. We just write it all out.
Yeah.
I don't know if that whiteboard is going to be big enough for you. Minus x squared minus x plus 2 all over delta x. And here's where we hope that magic starts to happen. Okay? So we got an x squared. We got a minus x squared. And those add to be 0 so I can eliminate them. We got an x. We got a minus x. We got a negative 2. We got a plus 2. Okay? You good with that?
Where did the minus x come from?
From this. The minus x came from
I see
that.
So you distributed?
You have to distribute. That's why I recommend using the parentheses.
Yeah.
We're subtracting that whole thing, which could be considered we're multiplying all that by -1 and adding it. Okay? So now we've got the limit as delta x approaches 0 of 2x delta x. This is in a random order, Jude. Plus delta x squared plus delta x, right? Yeah, I agree. And then all over delta x, and now we're going to start canceling things. So delta x, this delta x will cancel with that delta x. This delta x squared is just going to become a delta x. Now here's another popular mistake. What's delta x divided by delta x?
1.
It's 1. So I don't want to eliminate that. I want to make it a 1. So now we're looking for the limit as delta x approaches 0 of 2x plus delta x plus 1. Now we can put in 0 for delta x, and what do you get?
2x plus 1.
That's right. Now, I got news for you. Okay, if anyone's passed Unit 2 in here that's in calculus, there's this thing called a power rule. Okay? And if this is the function, the derivative is take the power, multiply it to the 1 less power. This says x to the first. Take the power, multiply it. 1 times x to the 0. Do you remember what x to the 0 is? Any number to the 0 power is 1. So look, that's going to be the fast way to do it. Only today, this is the last time you'll ever have to do this limit process.
Wait, so that works for every sort?
Yes, yes. What happened is they used the limit process to find the answer. And then they kept doing that. And then as it works in all maths, they found a pattern. And from that pattern, they built a rule so that they didn't have to do the annoying stuff anymore. So you're almost done with this. Don't think this is calculus, because it's not. This is actually pre-calculus. It's limit-based stuff. Whereas calculus starts to give you rules to do this more quickly.
Yes.
Okay? Boom!